We're going to prove that the limit as x approaches 0, sine of x over x equals 1. This is a very important function, sine of x over x. In class, we looked at the graph of sine of x over x, and it did appear to be approaching 1, but unfortunately, again, a graph isn't a proof, so to speak. So we have to prove this pretty much algebraically. Well, actually, we're going to use a lot of geometry, and we have this construction here. By looking at the drawing here, the area of OAD, let me highlight this for you. Ooh, highlighted. The area of OAD, this triangle, which by the way is a right triangle, is less than the sector OAC. So notice that triangle sits inside this wedge here. Now I want some pizza. And that wedge sits inside this larger triangle, OCC. All right, so let's write that down in words. So the area of triangle OAD is less than the area of the sector. I don't know if there is a notation for sector, so I'm going to put SEC for now. OAC is less than the area of the triangle OBC. Very good. Let me erase this because I have to clean this up a little bit. So notice that OA by design has a length of 1 if we're on a unit circle. So what else must have a unit circle according to this picture? Well, notice OC is another radius. So this is also a length of 1 right here. Good. So OA equals OC equals 1. Very good. We're going to need that information later on too. Basically, the whole idea behind this proof is mostly sleight of hand, meaning that we're making a construction to force it to work. It sort of seems like we're cheating here, but this is allowable. We're not doing anything illegal mathematically. Okay, so by definition of your trig function, the sine of x can be written as opposite of x of the smaller triangle AD over the hypotenuse 1, which is OA. That gives us AD. Cosine of x, again also of the small triangle, would be adjacent OD over hypotenuse, which would also be OA, which we said was 1. So the cosine of x is OD. Tangent of x. Tangent of x could be two things, because again we have two triangles, just like sine and cosine could have been. But for the purposes of the proof, we're going to use the larger triangle, BC over OC, and as discussed before, OC is 1. The tangent of x we could just say is BC. Alright, so we're going to need that stuff in a second. So, as you might recall, the area of a sector of a circle is just the formula. Let me write this down. Area of a sector. A is equal to 1/2 r squared theta. So now we have all the pieces parts ready as far as turning this statement here into the terms of the size of these triangles and sectors and whatnot. So let's start with the first one here. Area of triangle OAD. So recall the area of a triangle is 1/2 base times height. So it's going to be 1/2 its base is OD, its height is AD. Well, OD is the cosine of x, and AD is the sine of x, so we have 1/2. I'm going to put it in the format we typically see it in. 1/2 sine of x cosine of x. Good, so that's the first one. Now let's do the second one. Area of the sector OAC. Using this formula here, it's going to be 1/2. Our radius is 1. Our theta is x. So just 1/2 x. That's a nice and meet the ball. And our last one, area of the triangle OBC. Since this is a triangle, it's 1/2 base times height. OBC has a base of OC and a height of BC. OC is 1. BC is tangent of x. So 1/2 tangent of x. Great. So putting this together in this string, focusing on those inequalities there, we have 1/2 sine of x cosine of x is less than 1/2 x is less than 1/2 tangent of x. If we multiplied everything by 2, that would knock it off the halves. So I'm not going to write the halves anymore. And if we divided everything by sine, and we're allowed to do this because sine is positive, we would get the following. As I'm writing this, I want you to think about why we know sine is positive. The last one here, if we do tangent divided by sine, the signs would cancel, but remember that to give you 1 over cosine, don't forget the 1. So another way of saying what I just did in 2 steps, you could do in 1. You could multiply everything by 2 over sine of x, which again is positive because sine is positive in quadrant 1. If we took the reciprocal of all 3 parts of the inequality, the signs would have to flip. And we get 1 over the cosine of x is now bigger than sine of x over x, which is bigger than cosine of x. Hooray! Previously in class, we showed the limit as x approaches 0 of cosine of x equals 1. How nice! Well, here's where the squeeze theorem comes in. You didn't think that was coming back, but here it is. I'm running out of room here, but we can still finish this up. By evaluating limits here, as x goes to 0, where does the numerator go? It goes to 1. Where does the denominator go? That goes to 1. Thank you, squeeze theorem. All right, so the thing that is bigger than sine of x over x is going towards 1. The thing that is smaller than sine of x over x is going towards 1. So according to the squeeze theorem, where must sine of x over x go if the things that surround it are going towards 1? It must go towards 1. So that is the proof of the limit as x approaches 0 of sine of x over x equals 1. We had to use some geometry here. We had to use some squeezing theorem here. Ironically that we use the squeeze theorem because there's oh no, that'd be OJ, not OC. What are you going to do? Much better.